So, part of me doesn't like question A because pi over 4 is already on your pi plate. You know that cos of pi over 4 is root 2 over 2. And you know that sine of pi over 4 is root 2 over 2. Does it make sense that you could do A by doing this? Root 2 over 2 squared minus root 2 over 2 squared again. And that mental math is relatively easy because it's going to be the same number minus the same number, and you will get 0. What they wanted you to do in this question, though, was first write it as a single trig ratio. In other words, they wanted you to recognize that you have a formula that's cos squared alpha minus sine squared alpha. Which one is that? So you have to find it on the right-hand side of the formula. There it is. It's equal to cos 2 times whatever your alpha is. In this case, our alpha was pi over 4. And cos of 2 times pi over 4 would be the same as cos of pi over 2. Think about your unit circle. Add pi over 2 at the top. What's your x-coordinate? Your x-coordinate, 0. So you would have got an answer of 0 that way as well. But you probably wouldn't have chosen that. I think what we did first is more intuitive and easier. If you had to evaluate, it's already on your pi plate. Plug it in and figure it out. The same thing would happen in B. You know that tan of pi over 6 is root 3 over 3. You could just plug that in. You have fractions inside of fractions, so you'd have to work with your fraction rules to get a final answer that was a single fraction. But you could do that. When we look at the tan formula, that tan 2 alpha equals 2 tan alpha over 1 minus tan squared alpha. Can you see that B doesn't quite match? It's very close to matching the formula, but it doesn't quite match. So you would not be able to do any kind of substitution to the formula the way it is currently. However, if I, on the bottom, factor out a -1, do you see that the -1, taking it out of the bottom, would make the tan squared negative and the 1 positive? So I can rewrite it. It doesn't matter the order I write it. So I'll write it so that it matches up the formula nicely. Now this part without the negative matches up nicely on the formula. Some ideas of negatives and fractions. You probably know this, but you might not have known to use it in this situation. For example, did you know that if you have a fraction like -2 over 3, that it's exactly the same as if the negative was on the bottom? And that is exactly the same as if the negative was just out in front. All three of those are the same thing, just where you put the negative. So having this negative on the bottom of my fraction, really I could just imagine it out in front. And then what's in the green box, I'm going to keep the negative out in front, keep it black. Put the negative out in front, then this would match up perfectly with the formula, and I could rewrite this as tan of 2 times alpha, and my alpha is pi over 6. And 2 times pi over 6 is pi over 3, and pi over 3 is on my pi plate. Tan of pi over 3 is root 3. I'd still have that negative out in front, and I would get negative root 3. So actually in this question, if you evaluated tan of pi over 6 and got root 3 over 3, you'd still have a lot of mental math with fractions to do to simplify. Actually factoring out the negative and changing it to the double angle formula probably was easier, even though it didn't match up perfectly. So first of all, when using any of your identities, if things don't match up perfectly, you can't switch. You're like, ooh, close enough? No. Unless you think 0 is close enough to 3 that if I give you 0 to 3, you're like, yeah, I'm happy, right? So our identities have to be identical to switch them. Very important. Sometimes, like in this question, we could do a manipulation to make them identical. And that's fun. I factored out that negative on the bottom. That allowed me to get in the green box a match up perfectly. My alpha was pi over 6, and then I could substitute in. Okay, questions? Oh, I'm actually going to add to this one. See, I didn't like the numbers that the textbook used, so I'm going to add a C, and a D. And this one has been on the final exam. And on the final exam, they always tell you how many marks the question is worth. By the way, if they had given you a pi over 12 question, like evaluate sine of pi over 12, it would probably be worth 3 marks. Cos of pi over 12 would be worth 3 marks. And the number one thing I want to point out in this question is that you could figure out sine of pi over 12 on its own. You could figure out cos of pi over 12 on its own. And you could multiply those answers together. But then this question should be out of 7 marks. Because if sine of pi over 12 on its own is a 3-mark question, cos of pi over 12 on its own would be another 3-mark question, and putting that all together would be at least another mark. But it was only worth 2 marks. So do you guys know the strategy of seeing how much a question is worth, and then sort of realizing how much work you should probably show? If you can do a 5-mark question in one step, you're probably missing stuff, right? Okay, so this one's only 2 marks. So they want you to recognize this is your 2 sine alpha cos, oh, that's not green, cos alpha formula. What is that equal to? It's on the right-hand side. It's equal to sine of 2, whatever alpha is, and my alpha was pi over 12. That nicely reduces to sine of pi over 6, and that's equal to half. Okay. So it's really good if you develop sort of triggers for yourself, like, ooh, pi over 12. I know how to do pi over 12 questions. But sometimes don't jump into something right away without analyzing the question completely, because this is one that you could use your formula for. Okay? You can use your sine 2 alpha formula. And one more that we're going to do, I'm going to use 1 minus 2 sine squared pi over 8. Definitely something not on your pi plate, but this would still be a non-calculator question. Also be worth 2 marks. Which formula has 1 minus 2 sine squared alpha? It's like the third formula, right? It's a cos 2 alpha one, so we can change this. We have the right-hand side. We can change it. It matches up perfectly to cos of 2, and my alpha was pi over 8. Beautifully cos of pi over 4, which is on your pi plate. root 2 over 2. So these ones definitely you couldn't evaluate directly. Like A and B, you could have evaluated directly and got answers. These ones we had to use an identity in order to figure them out. Okay, did I tell you the questions to do already on this? Circle 4, 5, and 6.